Howdy, students. In this short video, I'm going to go over some of the math that you will need to solve the problems in Chapter 10 on exponential growth. Now, some of you may not need to know this. This is literally 10th grade math, but I realize that many of you may not have seen it since 10th grade, and therefore require a short reminder. So this might be very helpful for you to solve problems on the homework and on the exam. So let's start off with a problem. How many doublings does it take to go from 1 cent to $100 trillion? So you start out with 1 cent. After one doubling, you have 2 cents. After 2 doublings, you have 4 cents. After 3 doublings, you have 8 cents. And then you go on until eventually you have $100 trillion. So we want to figure out how many doublings it takes. Now, so let's talk about that. So the first thing you need to do if you want to solve this problem algebraically is to remember equation 10(2). And it basically says that after n doublings, something which is initially has a value of p becomes the value f. So f is a future value, p is the present value, and n is the number of doublings. So we can just plug in numbers for this. So f is the future value, that's $100 trillion. So 10 to the 12 is a trillion. So it's 100 times 10 to the 12, it's $100 trillion. And the initial value is 1 cent. That's 100th of a dollar. And so that's the equation we need to solve. 100 times 10 to the 12 equals 0.01 times 2 to the n. And so we want to solve that for n. So the first thing you want to do, and this is true in almost all algebra problems, is you want the variable that you're trying to solve for isolated on one side of the equation. So that means we need to move the 0.01 from the right-hand side to the left-hand side. And we do that by dividing both sides of the equation by 0.01. So one of the rules of algebra is you can always apply the same operation to both sides of the equation. And in this case, the operation is divide by 0.01. We do that, the 0.01s on the right-hand side cancel. And so we have succeeded in isolating the 2 to the n on the right-hand side. And so now the equation is 10 to the 16 equals 2 to the n. So now this is what we have to solve. Okay, so how do we solve this? So anytime you're trying to solve for an exponent, think logarithms. And so what we're going to do is we're going to take the log of both sides of this equation. And again, remember, you can always apply the same mathematical operation to both sides of an equation. So in this case, we're applying log to both sides. Now, one of the tricks of logarithms and why you want to use it when you're working on problems where you're trying to solve for an exponent is that a log allows you to take the exponent out and move it in front of the log. So we can take this n and we can move it in front. And this is the equation that we get. Log of 10 to the 16 equals n log of 2. Now this is just a straight algebraic equation because log of 10 to the 16 is just a number and log of 2 is just a number. So we can solve for n. And this is what we do. We calculate log of 10 to the 16, we calculate log of 2, we divide them, and that's the correct answer. Now, let's do a quick digression about logs. Now, you don't have to understand what log does. You don't have to understand what log base 10, natural log are. All you have to know is that there are various kinds of logs, and your calculator will have a button on it that either says log or it says ln. If it says ln, that's natural log. Or it might have both. It might have several log buttons. Now, it doesn't matter what kind of log you use, as long as you use the same log in the numerator that you do in the denominator. So if you do a log, L-O-G, in the numerator, then you have to do the same log in the denominator. If you do natural log in the numerator, you have to do natural log in the denominator. But it doesn't matter. You'll get the right answer in either case. Okay, so let's actually plug in some numbers. So this is a solution to the problem. Log of 10 to the 16 divided by log of 2 is n, or natural log of 10 to the 16 divided by natural log of 2 is n. So let's put some numbers in. So if we're doing the log version, the log of 10 to the 16 is just 16, and the log of 2 is 0.3. And if you divide them, you get 53.3 doublings, so about 53 doublings. Alternatively, if you want to do the second version with natural logs, you end up with the natural log of 10 to the 16th is 36.8, and the natural log of 2 is 0.69. If you divide them, you get the same answer. So that's really, again, the key. You can do it either way with any kind of log, as long as it's the same log in both the numerator and the denominator. So n is 53. And so now we can answer the question, how many doublings does it take to go from 1 cent to $100 trillion? The answer is 53 doublings. So I hope this helps. And let's end with your moment of dog.